Hello, welcome to University of St. Thomas General Chemistry 2 Visual Labs, Chemical Equilibria. The purpose of this experiment is to study chemical equilibria through different reactions. For introduction, chemical equilibrium is the forward chemical process proceeds at the same rate as the reverse reaction. Le Chatelier's principle: if a stress is applied to a system at equilibrium, the system will adjust to minimize that stress. Here we have two examples. If we remove some C, then equilibrium shift from left to right. We are going to look at three systems. The first system we will do together. We're going to record our observations. Number one, we're going to observe the color of the initial solution, which would be in the picture, and as you can see, it is orange. Number two, we're going to observe the color change of the solution after the 20 drops of NaOH are added, and the answer should be lighter orange. Next, you're going to mix well and divide equally between 3 tubes. Number 3, we're going to observe the color change after the additional 10 drops of NaOH are added, and it should turn yellow. Number 4, we're going to observe the color change after H2SO4 is added to the same test tube, and it should go from a yellow to orange color. Number 5, color change after H2SO4 is added to the second test tube. The solution should become more orange. Now we're going to go ahead and answer these three questions. Number 6, which reagents shifted the equilibrium position to the right? Give evidence for your conclusion. The answer is NaOH because solution became more yellowish. Number 7, which reagents shifted the position of equilibrium to the left? Give evidence for your conclusion. The answer is H2SO4 because the solution became more orange in color. Number 8, explain these shifts in terms of Le Chatelier's principle. Include the chemical equation in this explanation. Here's the equation. NaOH produces OH, which removes H plus from the solution, and the reaction shifts to produce more H plus. H2SO4 increases the H plus concentration, and the reaction shifts left to remove some of this excess H plus. Now we're going to move on to system 2, and you will record your observations. Here we are making the initial solution of FeCl3 iron chloride. Number 1, color of the initial FeCl3 solution. Number 2, color of the initial ammonium thiocyanate solution. Number 3, color of the mixture of iron chloride and ammonium thiocyanate. You're going to divide the mixture solution between 4 small test tubes. Number 4, you're going to add additional 5 drops of iron chloride to one test tube and record the color. Once again, the color changed after the additional iron chloride was added. Next, you're going to add additional 5 drops of ammonium thiocyanate to 1 test tube. Number 5, color change after the additional ammonium thiocyanate was added. Number 6, color change after the ammonium chloride is added and dissolved. Now you're going to go ahead and answer the following questions on the data sheet. Number 7, what is the color of iron thiocyanate compound? Number 8, an increase in the red color of the solution means the concentration of which species increased. Number 9, an increase in the yellow color of the solution means the concentration of which species increased. Number 10, what factors or factor shifted the equilibrium to the right? Give evidence to support your conclusion. Number 11, what factor or factors shifted the equilibrium to the left? Give evidence to support your conclusions. And number 12, explain these shifts in terms of Le Chatelier's principle. Include the chemical equation in this explanation. Now we're going to move on to system 3. Number 1, color of the initial CoCl2 solution or cobalt chloride. You're going to add 8 drops of water to the solution. Number 2, color after 8 drops of water were added. Now you're going to place the test tube in a water bath and heat for several minutes. Number 3, color after heated in the water bath. Now you're going to cool the heated test tube. Number 4, color after cooled. Number 5, color after LiCl was added or lithium chloride was added. Now you're going to answer the following questions on the data sheet. Which reagents or factors shifted the equilibrium to the right? State the evidence. Number 7, does the reaction produce or absorb heat when shifting the equilibrium from left to right? Give the evidence. Number 8, is this reaction endothermic or exothermic as written? Number 9, explain these shifts in terms of Le Chatelier's principle. Include the equation in the explanation.